And we're recording. Hey, Virge.
Hi, Mark. Hi, everyone. Thanks for joining us. We're doing episode 4 right now.
That's right. Our graphical STEM. One of the common questions, usually number 3 or 4 on the test, right?
So that means no calculator and also no lanyap because it would be common to A, B, and B, C. So everybody would need to know how to do this kind of question.
Right. And that QR code right there below us, you can point your phone at that, or you can go to the description on YouTube, click that link, get the PDF, work this free response, the 4 parts ahead of time, come back, and then we'll work through it with you again. All right.
So we're going to change
Um,
things up a little bit this time. Mark's going to lead us off.
Yeah. We also
So,
we're also at the end of things we had prepared to start a season 1, so
but the
have to
good
start
news
right.
is we have 4 years of material that we can delve into that
That's
we've
right.
written. So yes, we can
Yeah.
we can do plenty
The
more.
season will continue.
Yeah.
All right, let me get to my documents.
Yeah, Mark's going to do A and B and then I'll do C and D.
All right. So we have this graphical stem is what we call these, where they give you the Virge mentioned in episode 3 that the stem is the given part of the problem, which in this case is the graph all the way down to here. And got this graph, and then they describe to you. It says the graph of G, the endpoints are labeled, says let f be the function defined as f of x equals the integral from 0 to x of g of t dt. The graph of G is made up of 3 line segments, which we can see they are not lying to us, and the curve h of x, which is 1 plus cosine of pi x over 2 for the interval from 2 to 5. So that's this piece of the graph they are giving us with an algebraic equation or a trigonometric equation. Um, and then we get to the non-stem, the leaves, I guess. I don't know. Do you ever call them
Prompts,
anything? The
like a
prompts.
prompt.
Yeah. So it says evaluate f of -2, f of 2, and f of 5. So, we're going to be using this stem quite a bit. So I'm going to take f of -2. It's going to be the integral from 0 to -2. And then I'm curious, Virge, when you put that -2 there, do you keep it t or do you change to x?
Oh, it doesn't matter. I
And that
mean,
is that's that, I mean that's the correct answer, right? It
yeah,
doesn't matter. It's a
yeah,
numeric value. So
yeah. I thought you were going to
so
ask me about the limits of integration because you've got a lower bound that's actually bigger than the
no,
upper
that's
bound, and that always
crazy.
that always makes students
Yeah,
nervous. So
right
don't
here
worry if you're nervous about it.
I'm going from 0 to -2, which is like all the way down here, right? And
Hmm.
so yeah, the first thing I'm gonna do, I'm gonna put a negative in front, use my definite integral properties, and change that to -2 to 0 of g of t dt because I'm more comfortable with that. All right, and then we're going to just kind of use this area model. I've seen kids do it. Like you can make an equation of that line and do it by the fundamental theorem, but I think that's not the way Virge or I would attack it.
And by the
I'm gonna
way, we
parse it
are,
up.
even though we're evaluating f is a definite integral, so that does signal that we have to do area and not a
Yeah,
derivative or function value.
and something different. I know we're asking you to download these and look at them, but they are delivered digitally, and the graph is not printed on your page. So if you want to do exactly what I'm doing, you're going to have to come down here on your scratch paper or on your in your test booklet and kind of redraw this really quick if you want to kind of do that type of thing. Absolutely fair if you prefer to draw it. But what is the area of a triangle, Verge?
1/2 base times height.
Yeah, and so that triangle is 1/2, and I'm going to call the height -2. So that geometric representation of g of -2 being -2, or actually, sorry, yeah, that's right. That's the graph of g. Um, but
But
the
the
other thing to keep in mind is there's some symmetry here because the other one
but can I
is,
just interrupt for a second
yeah.
because the width is not 1 in that case. It's
Oh, you're
actually a
right. It is a
half.
half. Thank you.
Yeah. Uh-huh.
And the reason I didn't know that is because I did what I'm about to say when I did this myself. I can see geometrically that those are symmetrical around that point, -1.5. It's a rotational symmetry. And those are going to equal zero, right? You've got
Hmm.
to work that out. It's going to be -half and half. And
Hmm.
then we have this rectangle. So this is really just 1 times 2 equals 2.
With a
And
negative.
except I lost my negative. Give me a second. Jeez, you're
Sorry,
just sitting there.
sorry. I'll
You're
just,
waiting for that gotcha moment.
well, not really, but
All right, so we get the -2. All
okay.
right. And then f of 2. Now we're going to be doing a more traditional because we're replacing that x with a 2. So I don't have to reverse my bounds at all. We're now doing this section right here from 0 to 2. And that looks, what shape is that, Virge?
Another triangle.
It's another right triangle.
Hmm.
And everything's positive on this one. It's above the x-axis. We're going from left to right. And we get half of 2 times 2, which is 2. A lot of 2's running around in this problem.
Hmm.
Okay, and now we're going to look at f of 5, which is pretty involved. Uh, I was going to say, Virge and I were talking about these problems a little before we started, and I don't know if they'd ask for all 3 of these in one part on an actual AP exam. I feel like the first 2 are really easy, so maybe one of those in this one would be good.
Hmm.
So from 0 to 5, if I go back to my graph, we already have that triangle part. Now we've got this new curve, so we've got to remember that that's this 1 plus cosine of pi x over 2. So, uh, and Virge, I know the answer already, but I love definite integral properties.
I
Um,
do too. Love them.
and so I'm gonna, and I don't think I would show this necessarily when we talk about what do you have to show on the test. I think you could just replace that with the 2
Absolutely.
and just say 2 plus the integral from 2 to 5 of g of t dt. Obviously, I'm
Even
doing a
if you
little
weren't at,
more.
I think honestly, even if you weren't asked to find it, because it is a geometric
Yes.
solution that you can do very quickly in your head. So, anyway, I don't know.
Yeah, I
I
think,
mean, I'm not in charge of that stuff, but just based on a lot of things I've seen.
yeah. But I definitely think everyone reading it would be able to understand when they see that 2 to 5 what you did with that 0 to 2, especially having found f of 2 up here.
And it's correct.
Yes, and it's right.
Yeah.
Um, so um, to find a definite integral like this, I mean, we've seen this. This is almost an initial condition. Like, here's your first value, the one I
Yep.
know, plus the 2 to 5.
Yep.
So if you've watched videos 2 and 3, you know what to do if you have access to your web-based or handheld calculator. But unfortunately, this time we got to do it by hand, Virge. So what do I need to find that antiderivative? Oh, I just gave it away.
So,
So let's skip a step. We're going to find an antiderivative for fundamental theorem. What's
yep.
the antiderivative of 1?
X.
X. Excellent. So we got X plus. And then um, a lot of people do this with U sub. Virge and I have discussed this now already. And I know both of us, something like this where it's just a nice simple multiple. I'm going to come off to the margin here in my infinite paper and focus just on that cosine. And I'm going to try and write a little neater. It's tough on these corners. So because I've got this pi over 2 times x, the way I always think of it is like, what would the derivative of that be? And it would be pi over 2. And I actually read this out loud when I do this with my kids, like, "Durr." But I need a pi over 2 for my chain rule. And I think of everything a lot of times in terms of inverses. And when we take a derivative, chain comes out. So when I do an antiderivative, I need that chain to go back in. It's the same idea, it's just inverse operations. But I can't magically create a pi over 2 up front. If I want to multiply this thing by pi over 2 and I really want to multiply by 1, what else do I need, Verge?
2 over pi. So it's
2
really
over
the
pi.
reciprocal.
Yeah. So instead of having the multiple come out when we take the derivative, the reciprocal comes out when we
Hmm.
do the antiderivative. And so that'll become 2 over pi. And then this will become sine pi x over 2. So this can be a margin note. This can be happening mentally. This is definitely a skill the readers expect you to have and don't need to show that. Um, and then double check your signs, right? Sine and cosine, they sometimes they change signs, sometimes they don't. I always check it by taking what's the derivative of sine? Positive cosine, so I'm okay here. And I would chain that out and get pi over 2. So I insert my 2 over pi sine of pi x over 2.
Mm-hmm.
And I'm going from 2 to 5. So now we start our final run.
Mm-hmm.
Take that upper bound or upper limit of 5 and substitute that in. I am going to call that 5 pi over 2. That feels like a number I should know.
Yeah, it's kind of like unit circle adjacent.
Yeah, circles. Units.
Mm-hmm. Make the
Uh,
Cinnabon around and around and around.
that's funny. I would have expected you to go Princess Leia curls, but
Oh, no, I think more like the big cinnamon rolls.
that's what she had on the side of her head, wasn't it?
Mm-hmm.
All right, and I'm actually not even going to write equals. That is a perfectly fine numeric answer on the AP pre-response. On a multiple choice, you're going to be expected to evaluate that, and it's feeling a lot like a 1.
Mm-hmm.
This
Yeah.
is pi, so that's feeling a lot like a 0.
Yeah, it's not going to be hard to evaluate it. Yeah.
It's actually not that bad at all, is it?
Mm-mm.
2 minus 2, and so it's just going to be 5 plus 2 over pi.
Great. That's what I got.
Yay.
Oh,
So
was that only part A?
I know part A is long.
Oh
That's why I
my
said that is not
gosh.
a typical AP question.
Okay. Okay. I'm sorry. I'm sorry. You're doing part B. Go for it.
Okay. So for part B, I'm going to go back to my graph and I'm going to erase the little bit of writing I did on there. And they asked me, they say, identify open intervals on which f of x is increasing and concave up and explain your reasoning. So we're actually for two different things. And we talked about this in the last video. You don't get points for stating definitions, but I think it's a good idea, right? Like we want to get our thoughts. Um, we have this relationship that f of x is the integral from 0 to x of g of t dt.
Mm-hmm.
And so f prime of x, well, this is the other side of the fundamental theorem. We use the integral part for part A. This is the derivative part. The derivative of the integral of that could be g of x. And the second derivative of f then is the first derivative of g.
Mm-hmm.
So which of those is going to tell me something about where f is increasing?
F prime has to be positive for F to be increasing.
Yeah. So we've got f prime for f to increase, and then for concave, we need that second derivative.
Yeah, second derivative has to be greater than 0. But I like to go back to the fact that we
But
really need G prime to be increasing since we're
yeah,
looking at a graph of G. Yeah,
that's
that's.
that's the one. That's the one we're going to need here for our explanation,
Mm-hmm.
because you want your explanation rooted in what the problem has told you,
Mm-hmm.
and the problem has given us information about g. It has
Right.
not given us information about g prime. If I want to claim that this f double prime of g prime is positive, then the next question is, well, how do you know that? And we know it because g prime is increasing.
I guess that's going to be true on the F prime as well. We really need to say that G is greater than
Yeah.
0.
And like I said, those weren't intended to get any kind of points.
Yeah.
Those are just me organizing my thoughts.
Mm-hmm.
So this picture is G, which is F prime. I want to look at where it's increasing because that's my concave up.
Mm-hmm.
And I want to know where it's positive because that's where G will be increasing. Or sorry, where F will be increasing.
Mm-hmm.
So that's all of this.
Yeah. It's a lot. But we're
But
only
what I
looking at the overlap.
yeah, we want the overlap and only the open overlap, so we don't have to worry about endpoints or anything like that. So it looks like that's at negative 1.5 to negative 1,
Hmm.
and from 2 to 4. So let's see, from negative 1.5 to negative 1, and from 2 to 4. Because fate, that's an unusual spelling of the word that, because that's where f prime equals g is greater than 0,
Hmm.
and where f prime equals g is increasing.
Great.
Okay, now I will stop my share. You can take it away.
And I will share mine. Let's see how this looks. Okay, there's
Looks
my
good.
stem, same as what you had. Surprise, surprise. And on part C, we're being asked to identify critical numbers on f of x for negative 2 is less than x is less than 5. Once we do that, we have to evaluate f double prime at each critical number or state that it doesn't exist. Show reasoning. Okay, so one thing that my students know is that Mark loves to call the critical numbers the crits.
That's right.
And now everybody knows it.
I'm
My
gonna, I'm
students
gonna,
love it. They're like, we have
I'm,
to find the crits. They love it.
I'm gonna write a musical one day, and one of the gangs is gonna be the crits.
I know. It's such a gang name, isn't it? Okay, so the crits are going to be where f prime, where f prime is equal to 0. Is there any other place where I might have a critical number?
I need to look back at the graph. Let's see.
Well,
So need 0. So it looks like negative 1.5 and 2.
well, I'm just saying, or is there any other place where there's
Oh,
going to
I
be a
see what you're saying.
critical?
I'm sorry.
Yeah.
Yeah. So it has to be in the domain, and then f
Mm-hmm.
prime has to be 0 or undefined.
Uh-huh. Right. Okay.
I'm sorry.
That's okay. I think that this one's a kind of a moot point for our graph, but well,
Yeah,
I don't
since
know, maybe.
we've been given a continuous graph of the derivative, right?
Yeah. So we know the relationship that f prime of x is equal to g of x. Okay, so that means that this is where g is actually equal to 0, right? So I see two spots where g is equal to 0.
Spoiler, I gave those away. Sorry about that.
That's okay. X is equal to negative 1.5 and x is equal to 2. Now, for each of these, we're supposed to find f double prime. So what we need to do is think about the fact that when we had that on the other one, that f double prime is equal to g prime. So we want to think about the slope. So
Right.
at a negative 1.5,
And the slope of G specifically, right?
right, right,
Because it's a
right.
line.
The
Because it's
slope
a
of
line
g.
segment. Yeah.
Right, slope of g. Right, so f double prime of negative 1.5, this is a line segment. So I could think about rise over run, which is how I would do it. But if you feel more confident just thinking about doing your y2 minus y1, you could do that also because this is negative 1 comma 2. But I believe that this is 4 over 1 or just 4 for that answer. And then f double
I would
prime.
have totally done the same thing. I would have counted it off. I would have
Yeah.
counted the 4 up and 1 over. Yeah.
And by the way, sometimes there's going to be a grid on the back of this so that you actually can count up and over more easily. It kind of is a toss up. Sometimes you'll see a grid behind it, sometimes you won't. If you look at recently released FRQs, you'll know what we're talking about. All right, what's going on at f double prime of 2, which is the same as g prime of 2, which means the slope on this graph at 2?
Yeah, it's not changing well there.
Yeah. So they're saying, or state that it doesn't exist. I would say it doesn't exist.
Yeah, I agree. I think, yeah, like I said, the other point was on one of those 3 line segments, and this is where that line segment is meeting that curve, and they can meet smoothly, but they're not.
They're not, especially because we know the behavior of cosine. There's going to be a horizontal tangent down here, and then this is
Right.
coming in at a -1 slope. So,
Yeah.
yeah, I would say does not
Uh,
exist.
Now you do have to show reasoning, so you can't just
So,
say
what
it
else do you
doesn't
want me
exist.
to say? Because um, we don't have to justify, but
Right.
we might say there is an abrupt change in slope. Would that be enough?
Yeah. Yeah, that'd be or a corner. We could describe it as a corner, right?
Okay. There's actually, to me, like a, yeah, okay, we'll say a corner at x equals 2, or there's an abrupt change in slope.
Abrupt change is a nice, yeah.
Yeah.
They're pretty lenient on that as long as you get across that idea that you're having this abrupt change,
Hmm.
that verbal explanation of that. If there was a formal scoring guideline for this, you can see it. You can ask your teacher to look up 2017, one of the common questions, and they give the limit definitions from one side and the
Oh,
other.
yeah.
That's what you would need if it asked you to justify. So
Hmm.
it's worth looking at. But if you're not being asked to justify, they're very generous with as long as you can explain that idea that you could even write, right? The slope from the left is -1. The slope from the right is 0. So they're not meeting up well. You could do it verbally.
Hmm. Yeah, that's good. Okay, then part D, which I have right here. It says find the value of the limit of this quotient here as x approaches -1, or show that it does not exist. Justify your answer. Well, whenever you're doing a limit, you should just go ahead and do a direct substitution first, in my opinion, and just see what you have. So when
I
I
always
said,
start with the denominator too,
yeah, so
because if the denominator is 0, game's over.
to a certain extent, I mean, we can't just automatically use L'Hopital's rule, though.
But you're not going to be able to substitute anyway, because if the
Oh, I
top's the
see what you
constant,
mean.
you're going infinite or negative infinity.
Right. But I'm like always chomping at the bit. I want to use L'Hopital's rule, so like I really want
Yeah,
to verify that.
I always check the bottom just to know if I can plug in. Because
Yeah.
if I get a number in the bottom, I can substitute for both.
Hmm. Ooh, here's that word justify, Mark.
Ooh,
So
yay!
we're going to do another thing that I told my students that Mark always does, and that is make a zero sandwich.
I,
So I'm going to say I'm going to be checking my numerator and denominator because I'm probably going to be needing to do L'Hopital's rule is my guess. Let's see what I
and
get
even
the
if
new.
you don't, you can put them back together, right?
Yeah,
So
that's true. Um, so I've got f of -1 plus 2 times -1 squared. Let's see, f of -1 is equal to 2.
nope, that's g of -1.
Oh, jeepers. Okay, hold on a second. Let me not
Yep, we have to
erase
go
my
back to our
stem right here.
integral definition. Yeah.
Yeah, I was about to say 2 plus 2 is not going to equal 0. This is not going to end well. Okay, rewind. Okay, so we've got f of -1. So f of -1 is equal to something we have not yet found. This is going to be the integral from 0 to -1 of g of t dt or g of x dx, doesn't really matter. And then as I look at that, I do like to change my bounds so that I have the
Absolutely.
lower one on the bottom. And then that's just a rectangle. So I'm going to say that that's going to equal -2 because I
Yeah.
have an area of 2 right there. Okay. All right, let's see about that. So -2 and then plus 2 is 0. So all that
-2
to
plus 2.
say, thank you. All that to say that I still do need to check my denominator, and I've kind of run out of room to do my zero sandwich, but I'm going to try and squeeze it in. And I know, because I can just do this by inspection, that the limit as x approaches -1 of x plus 1 is also equal to 0.
Yeah.
So therefore, L'Hopital's rule applies.
And I don't know how important this is for you, Virge, but
Hmm.
I would like to see a parenthesis on that argument on that first limit.
Okay, sounds good.
But yeah, and that's what I was saying. Like if you check the bottom and you get a number, then L'Hopital's can't be used. But
Mm,
if you get 0 or infinity on the denominator, now you got to think about it as a
right.
possibility.
And L'Hopital's rule means that if you are in this indeterminate form of 0 over 0 or infinity over infinity, then you can take the derivative of the numerator, the derivative of the denominator and try again, plug in
Yeah.
again. So I think you would probably take the derivative of the denominator first, is my guess. Since that's pretty easy, you get 1. Derivative of the numerator is going to be f prime of x plus 4x. That's a power rule right there. So f prime of -1 is going to be, hold on, I can't write and talk at the same time. Okay, f prime of -1 is kind of what I was talking about before because f prime is equal to g. So it's the same as g of -1, and g of -1 is +2 up here. So that's 2. And then we have -4 all over 1, so -2.
And I just want to say also, we are doing something with the function with both f of -1 and f prime of -1, where we
Mm-hmm.
are evaluating the limits just by plugging in. And what allows us to do that is we know that both of those functions are continuous. That
Mm-hmm.
a continuous function, the limit value is equal to the value of the function. Um, I don't know if they there was one time it was asked to be mentioned because it was tabular. I think because you're given the graph here, you can just use it. But
Mm-hmm. And you don't have to talk about why you're allowed to be using
right,
it. Yeah.
yeah, I wanted to talk about it because I think it's important that
Yeah.
we think about that in the background. Because if that graph wasn't continuous, if there was a jump discontinuity or something, then you wouldn't be allowed to just plug in the function value.
Well, all right. We've come to the end of episode 4. And thanks for hanging with us, the 3 of you that are still here. Well, the
It's,
one of you, Mark, me, and the one of you. Just kidding. Okay. Um, I don't know, Mark, you want to take the screen again before we
I was
go?
trying,
Okay.
trying. All right, I think we have it. Hi.
Bye.